All right, everybody, for the past couple of days, we have been working with radicals, identifying parts of a radical, simplifying radicals, and today, in this video, we're going to learn how to actually add or subtract radical expressions. And so that is our essential question. And our learning objectives, the first will be to add or to simplify the sums of radical expressions, and our second learning objective will be to simplify the difference or do subtraction on radical expressions. So looking at learning objective 1, adding radical expressions, what I want you to recall is how we add terms with variables. So looking at this first example right here, I have 7x plus 4x equals 11x. When I give you something like 7x plus 4x, your first question should be, well, can I combine these two things? And the answer to that should be yes, because the variable that is present in both of the terms is x. So once I confirm that I have like terms, I'm going to go ahead and combine like terms. And to do that, I'm just adding the coefficient 7 plus 4 to get 11 and keeping that variable x, giving me a final answer of 11x. So big takeaways here are my variables the same? Same. And because my answer is yes, I know that means I can combine like terms. If I look at my second example here, I'm kind of in the same boat. I have 2y plus 5y. I'm asking myself, do I have the same variable? The answer is yes. And so I'm going to go ahead and add my coefficients 2 plus 5 to get 7. And then I will keep that variable y so that my final answer is 7y. So once I know that I have like terms, when I combine them, I'm essentially adding the coefficients, which again are the numbers in front of the variables, and I'm keeping the variable. However, in this third example here, 3x plus 4y, when I go to check if my variables are the same, I see that in the first my variable is x, but in the second term my variable is y. So since my variables are not the same, my final answer is going to just remain 3x plus 4y. There's no way for me to combine those two terms because I don't have like terms. So our big takeaway there is without like terms, I cannot combine further. And I wanted you to recall this because all of this, right, the method that we use to combine terms with variables is very similar to how we add or subtract terms with radical expressions. So if you take a look over here on the right side, if you notice, my coefficients are 7 and 4 just like they were over here in that first example on the left. The major difference is that instead of having my variable as x, I have radical x and radical x. But my radicals are the same, okay? So that's the question you're asking for number 1. Are my radical expressions the same? And in order for the radical expressions to be the same, I need same index and same radicand. So in both of these cases, my index is 2. Because again, even though I don't see a little number, I know that that means the square root. And also my radicand in both cases is x. So in other words, at this point, I have like terms. And since I have like terms, I'm going to add these two terms together the same way I would as example 1. So I add my coefficients 7 and 4 to get 11, and I'm going to keep that square root of x, and that would be my final answer, 11 square root of x. Now, in the second example here, I have 2 root 3 plus 5 root 3. If I ask myself, do I have the same radical expressions? My answer is yes. In both cases, I'm dealing with the square root of 3, square root of 3. So my index is the same and my radicand is the same. So I'm going to go ahead and handle this the same way as example 1 and just add my coefficients together. 2 plus 5 gives me 7, and I'm going to keep that square root of 3. And that is my final answer, 7 square root of 3. So the takeaway here is, if I have like terms, meaning same radical expression, then add coefficients and keep the radical. So you should see how this is very similar to, the two examples on the right are very similar to the two examples on the left. And that pattern is going to follow. When I look at example 3 here, 3 root 5 plus 4 root 7, if I ask myself, do I have the same radicals? Well, in the first term, I have a square root of 5. But in the second term, I now have a square root of 7. So although my indexes are the same, my radicands are different. My radicand for the first guy is 5, and for the second guy is 7. So since I don't have like terms here, there's no way for me to further simplify this problem. It is going to stay 3 root 5 plus 4 root 7. And so example 3 on the right is very similar to example 3 on the left. So the big takeaway, if no like terms, meaning radicals are different, then cannot simplify further. Okay, so the idea here is we can combine and we can simplify when our radicals are the same. And that main idea is going to stay consistent as we even move on to learning objective 2, subtracting radical expressions. So right at the top here it says subtraction works just like addition, where combining like terms is key. So if we take a look at this first example, okay, I gave you 7x minus 4x, 2y minus 5y, and 3x minus 4y. Those are also actually the same exact examples as before, it's just they're subtraction now instead of addition. So for this guy, I have x's, so what do? Subtract my coefficients. 7 minus 4 gives me 3, I keep the x term. In the second one, do I have the same variables? I do. They're both y's, so I subtract the coefficients. 2 minus 5, negative 3, and then I keep that variable y. Down here for the third one, my variable in the first term is x, but my variable in the second term is y. So since they are not like terms, 3x minus 4y stays 3x minus 4y. What I want you to note here is that we're actually handling these problems the same way as addition. For addition, however, we're adding instead of subtracting. So let's take a look at the radical expression examples now. Number 1, 8 square root of x minus 3 square root of x. Again, my first question every time, are my radicals the same? Meaning same index, same radicand. And if I look, I have the square root of x and the square root of x. So, since I have the same same radicals, I go ahead and I take the coefficients and subtract them. 8 minus 3 gives me 5, and I go ahead and I keep that square root of x. In the second example, same thing. Do I have the same radical? Meaning same index, same radicand. I take a look, I have the square root of 3 and the square root of 3. They're the same. So I'm going to go ahead and take 55 and 5, the coefficients, and subtract them. 55 minus 5 gives me 50, and I will keep that square root of 3. Finally, example 3. Are my radicals the same? Well, in the first one, I have square root of 5, but in the second one, I have square root of 7. So even though my indexes are the same, my radicands are different. The first one is 5, the second one is 7. So 4 root 5 minus 6 root 7, is just going to stay 4 root 5 minus 6 root 7. So the takeaway that you should get from this video, okay, we can only add or subtract radical expressions if the radicals are the same. Or in other words, we have like terms. When adding or subtracting radical expressions, we are really adding or subtracting the coefficient, or the number in front of the radicals, don't get that confused with the indexes, and keeping the radical the same. Okay, so that's it for adding and subtracting radicals. Please make sure you fill out your notes and do the Google form that is attached to the assignment. I will see you all tomorrow.